15 years ago, I built what I affectionately like to call
the most dangerous CNC router on YouTube.
the machine ran great, but when I decided to upgrade my spindle, CNC fever took over, and one thing led to another. What started as a simple upgrade turned into a complete system rebuild. By the end of this video, you'll see exactly how I got every one of these circuits to talk to each other. It all comes down to some relays and a switch panel I designed myself.
This is that story.
Back then, I was much younger, and so was YouTube. There was no deep library of build videos to learn from, and there was no AI to consult. So I did what I could with what I had.
And what I had was a passion, and a basic understanding of how to make it happen, and way more determination than money or experience.
It wasn't the fanciest machine out there, but it worked. And it was mine, and there was no denying it.
I had full-blown CNC fever.
Fast forward to last fall. I decided to revive my old YouTube channel. The niche wasn't hard to pick. CNC has been my passion ever since that first MDF machine. And my trusty homemade router sure could use a little TLC and a few upgrades.
The machine and I have been through a lot together. And apparently one, or maybe both of us, have become dangerous enough to cause concern to the faint of heart.
It was time to do something about that. Better motion control, dedicated circuits, automatic dust collection, and replacement of that tired old router was long overdue. I needed to upgrade it to a proper spindle, which meant I needed a VFD.
So what do you know? A VFD ended up on my Amazon wish list. And my 86-year-old mom, who I am certain had no idea what she was buying, found that wish list, purchased it online, and had it wrapped up and under the tree for Christmas morning. I couldn't be more proud of her. She truly is an amazing woman. And just like that, the upgrade was no longer optional.
By New Year's Eve, the upgrades to my machine were underway. I already made a whole video on the spindle and VFD, so I won't go into that deep here. But long story short, I decided to replace the old router with a water-cooled spindle. Because they're so much quieter than air-cooled. The only time you really hear them is during heavy cutting.
And on a long job, a lot of time is spent on light passes or just machine movements.
And plus, at 2.2 kilowatts, the new spindle is a considerable upgrade in power from the old router. Now I have the largest, quietest, most powerful spindle that is practical for my machine.
Done.
But water-cooled means a coolant pump. And I already knew that automating dust collection was going to push the limits of space in my existing cabinet.
The coolant pump is what finally burned down that dangerous old cabinet. And honestly, I'm happy to see it go.
So I grabbed a notepad and began to plan out the new cabinet design.
Boy, had I opened a can of worms. Somebody stop me. This was more than a few upgrades. This was turning into a system rebuild.
But all of these upgrades meant I had to face a decision I'd been avoiding. And it was gonna cost me either way. You see, command and control for the whole system was a 20-year-old computer running Windows XP.
Now don't get me wrong. Everybody knows that Windows XP is mankind's greatest operating system. There hasn't been one as good since, and there likely never will be by the looks of where things are headed. But then, those were different times now, weren't they?
Yes, I love Windows XP, and so does Mach 3. But they are both outdated and fading into the ether.
Or Ethernet, to be more precise.
So that meant I had to choose a new operating system and control software that had a future.
Maybe a nice new Windows 11 machine. Yeah, not on your life. And then there's Linux CNC on my milling machine that I'm building and debugging. But at this point, Linux isn't the route I want to go for my daily driver.
Then I got thinking about my wife's recently, and let's just say, involuntarily scuttled Windows 10 machine in the attic. Yeah.
That might work. Thanks, Microsoft. So that settled it. Windows 10 it is. But what about motion control?
Modernization meant one thing: Ethernet. But which one?
Being a Mach 3 guy, the natural progression would be toward Mach 4. But for some reason, Mach 4 doesn't appeal to me.
Maybe it's because I already own Mach 3 and don't like the idea of buying twice. Or maybe it's because I've heard it's intended for more than your typical hobbyist situation anyway.
Whatever the hesitation, the more research I did, the more I eventually had to address the elephant in the room.
CNC Drive makes so many great controllers. Why not make the switch to UC CNC?
It was a risk, for sure. But, as has already been well documented, I like to live dangerously.
So I did it. I pulled the trigger on an AXBB-E controller. It has a built-in breakout board and plenty of inputs and outputs for what I'm going to do with room to spare.
I have no idea what I've gotten myself into, but stay tuned. I'll be sharing my UC CNC experiences with you as they unfold.
Well, with all that settled, I thought I was done planning and ready to build. Boy, was I wrong. There was still more to come.
One thing I love about the CNC Fever community is that it's a safe place to bounce ideas off one another and to learn from each other.
So when one of my viewers suggested upgrading my drivers and power supply too, it got me thinking. But it was his assurance that I would experience a noticeable difference with the modern digital drivers and more power that pushed me over the edge.
I mean, who doesn't want more power? So I ordered 3 shiny new digital drivers and a 48-volt power supply to replace my 36-volt. It just makes sense.
But this sure has gone from a simple upgrade to more of a forever type of upgrade for this machine. All the components I used are linked in the description below. And now, after all the planning and deciding, it was time to give all this new technology a fitting home. This cabinet design represents my evolution as a builder.
Oh my gosh, that looks so good.
It's not perfect, and I'm sure many people would do some things differently. But that's okay. I'm proud of what I built, and I guarantee that it will function as designed. The first thing you'll notice is that I've chosen to use PVC conduit for clean routing and to protect my wiring from mechanical damage. This has nothing to do with code compliance or anything. I just thought it made good sense in this environment, and it keeps things neat and tidy. You can also see that I've added ventilation for warm air to escape and a fan with a filter at the bottom blowing cooler air in. The fan not only moves air through, but it also provides positive pressure in the cabinet, which should keep dust from leaking in unfiltered. The AC power comes in through this cord. I've provided strain relief where it enters the conduit so that there is no strain where it connects to the disconnect switch. This is the main on-off switch for the cabinet power. Big, visible, and close to the machine in the event of an issue. Following the power, let's look inside. Here the power comes in and the ground and neutral wires land directly on their designated buses. The hot lead goes to this 10 amp breaker. We can debate whether a breaker is needed here. The circuit is already protected by a 20 amp branch circuit, so technically it probably isn't. But having a local lower amperage breaker will trip sooner and better protect the control box and all these expensive electronics if something does go wrong. From the breaker, the hot leg then lands on the AC hot bus. Inside the cabinet, AC power gets distributed to 3 places. It goes to the 48-volt power supply, which drives the stepper motors. It goes to the 24-volt converter to provide 24 volts for the relays and cabinet electronics, including this buck converter, which outputs 5 volts DC for the logic circuits. The last AC output is switched at this relay and goes to the contactor coil on my dust collector. I wanted to use 24 volts DC for this, but component availability and affordability led me to use a contactor with a 120 volt AC coil instead. The contactor needs to be rated for motor loads, and the 24 volt DC versions either weren't rated for motor loads or were prohibitively expensive.
Well, that sums up the AC side. The DC side is as I alluded to already. Most of that's pretty straightforward, but the relays are where things get interesting. I needed to automate spindle start, coolant pump, and dust collection, all triggered by the machine itself, while preserving the ability to run dust collection manually from my table saw and other tools. I also thought it might be beneficial to be able to run the coolant pump manually too. Before I get into my setup, let me say there are many ways to approach this and many different solutions.
This is how I chose to proceed. This is what I call Relay 1. It's a 2-pole relay, meaning it can trigger 2 separate circuits when activated. Relay 1 is triggered by the Spindle run command in G-code, or M3. When the relay is activated by the M3 command, it closes a circuit on the VFD run circuit and the spindle starts. At the same time, on the other pole, 24 volts is switched on for my automatic circuits. These power the dust collection and the coolant pump circuits while in auto mode. And then there's Relay 2. When activated, Relay 2 simply provides power to the contactor coil on the dust collector. This relay can be activated in one of 2 ways, with 24 volt power from the auto circuit or from the manual circuit.
The whole system comes together here on the cabinet door. And if you enjoy this kind of content, make sure you're subscribed.
First, we have the HOA switch. HOA stands for hand, or what I call manual, off, and auto. This selects which mode I'm operating in. For normal CNC operations, I'll be in auto mode, indicated by this green LED. That means everything is good to go, and both the coolant and dust collection will activate automatically. If I change the selector switch to hand, I'm now in manual mode, indicated by the red LED. This means nothing is triggered automatically. While in manual mode, this secondary on-off-on switch becomes active, which allows me to operate either the dust collection, the coolant pump, or neither one. This allows me to still operate dust collection for my table saw and other tools, or to run the coolant pump if I need to prime it or service it. When dust collection is active, it illuminates the yellow LED. When the coolant pump is activated, it illuminates the blue LED. As for the actual dust collection, I have blast gates that are opened and closed manually throughout the shop depending on which station is being used at the time. I designed this HOA panel myself, and the 3D print file is available as a free download on cncfever.com. I will also be posting the wiring diagram for the relay circuits there as well. If they are not there immediately after the video is published, check back in. It'll be posted soon. Also, everything you see in this build, the switches, the relays, the drivers, the power supplies, it's all linked below if you want to build something like this for yourself.
So, there it is. Is it done? Well, that depends on your definition of done. The cabinet is built and the components are in. The wiring is clean, although I do still want to put this enclosure over the wiring on the back of the door here. I just got that off the printer earlier today. But overall, the system's up and running. 15 years ago, I built what I affectionately like to call the most dangerous CNC router on YouTube. Today, I'd like to think I've tamed it. Not because the machine ever let me down, but because I finally built the control system it deserves. If you want to see all the shenanigans that led up to this system overhaul, the full playlist is linked right here. And remember, CNC fever is real, but treatment is available. See you next time.